Welcome to assembly part of our video. Here I'm going to explain how you can get your Raspberry Pi in Eurorack fully assembled and what parts you actually need. First, you need to get that faceplate, which is aluminum faceplate painted in black. And you'll be surprised, you have two options. You can use it as black, or you can use it as real aluminum. If you just flip it. All the components here are fully symmetrical, so no matter, well, how you put it, it still fits. Like USB connectors and the breakout board will fit either side. Okay, let's start assembling that in a normal way. So the first part that you need, of course, despite the fact that you need a Raspberry Pi that you have to have ready, you need a display. And there are several display options. This faceplate is in particular designed for some specific display model that I found the best that fits the needs today market. So it has to be, there are several options like this, or like this. First of all, it has to be 5-inch. So this one is no go, this one is 4-inch. Second one, if it's 5-inch, the model that I'm using, it doesn't use the HDMI connector. So if you find a display that has HDMI connector on the side or on top or bottom, that will not work. It's simply too messy. There are too many cables. You have to connect HDMI, you have to connect the USB for power and touch. So this one is no go. Even it's a 5-inch, even it's a decent resolution 800 by 480, it doesn't work, it does not fit. So no go. The model that actually works, this one, it's 5-inch. The particular brand I have here, well, it's called K-Day, but I found there are many displays like this without this logo. So again, it's a 800 by 480, it's the same resolution as before. But unlike these HDMI header boards, it used what's called DSI interface. DSI interface is, this interface. It connects with a flex cable straight into the display interface of Raspberry Pi. So that makes it much easier, simpler, and better looking. There are no extra cables. So that's regarding the display. Again, the BOM guide that has all the references to the models and the link to a particular one. This costs roughly between $35 and $40, depends where you buy it, including shipping. All right, it also has a capacitive touchscreen, which is also great for us. So the way you mount it, basically, of course, you need to take the plastic protector first, and then you put it here, and then you tight everything together. Before doing that, first we need to assemble it with Raspberry Pi. This display, it comes with a standoffs. It's a 2.5mm standoffs, and it is assumed that you have the Raspberry Pi mounted on top of this, and then you have the flex cable that connects these two. So it goes from the Raspberry Pi to the board. The problem here that Raspberry Pi 4 in particular is pretty warm device. So I highly recommend you use a heatsink solution on top of that. And there are multiple heatsink options. There are just small aluminum heatsinks that you can just glue on top of these with thermal interface. There's something more robust, including active cooling. My problem that when I designed this, I wanted this to be passive cooling, and I wanted it to be reliable, so it doesn't really requires any external airflow, and it can stay powered on under the load for many hours straight without nothing needed else. So to get it working, I found the heatsink solution that I really like. This one. Again, the link in the bill of material. This assumes that you have Raspberry Pi here, you put it here, and then you close it with another part. As you see, this doesn't look to be, and then everything is such a great design and perfectly. The only problem here, you see, it's already modified. The problem with this solution that it needs a bolt going from this side. Because, well, this side, it has threads for these bolts. And that's not what we have here. So the option would be basically disassemble the display, deattach all of the flex cables. That's the risk to damage the display. Instead of that, what I recommend, so you put it like this, then you put the board and this solution. And to get it working, you have to drill through here. So now instead of threads, you just drill through and use long bolts like this. This is 2.5mm hex. It goes straight here, and then you use a screwdriver to go from here, and then everything will be locked. So the problem that you have to drill, you have to do that accurately because this is aluminum, great material. But it's too soft, and yeah, you need to make sure that you don't really damage it that much. As you may see, I did damage on my first unit that I used for many experiments here. So it only has 3 bolts. This one is missing because there is a small piece here, and I didn't like it. It's good enough even with 3 pieces. So I'm not really that much concerned about this. Before assembling it, you also would be better if you put a thermal interface between this part of the heatsink and the board, because if you put it like this, they are not attached to each other, because otherwise they will make a short. So what I recommend here, you use the thermal interface, which comes in a different thickness. I'm not sure, this one is either 3mm, they go in millimeters, or 2mm. And you put it like this. You see I already used it, and well, used it for quite a long time. And then you put board on top of this, and now they are attached to each other, so the thermal will transfer from the opposite side of the board to the heatsink on the back side. And there is enough space here, so everything will be perfect. Alright, so that's for this part. You have to do the similar for the components on this side, because, well, obviously there are some aluminum different heights here. So it still assumes that you have some small heatsink material. It's better to use 1mm heatsink material that you just cut in pieces. So this piece would be for our CPU. This piece would be for memory. Goes like this. And this one, I'm not quite sure. I think it's, well, it's network. So, and then you close all together. Yep. You can see that it's hard to see here, but basically everything is connected and attached together. And then all you do, you just screw that together. So to do that, you see one is broken, so I'm using one of the original screws that came with this heatsink. I'm using it here. And then I'm using these long 2.5mm hex screws, which, by the way, I bought on Amazon as a whole box of different sizes. You can get it cheap. And now you can play with that. So, oh, I made a mistake. Same mistake as I made when I initially assembled it. To put it together, before I close this, you need connect flex cable to display. So you connect it here. Like this. Then you lock it. So it's in lock position. Make sure they are equally tight. So don't try to tight one and then other two. Just do that equally, like same way how you change the tire on the car. Exactly the same way. And so now that other remaining piece of the flex cable, it goes, if I remove it, it goes to this connector. So the way it works, you just put it like this. Again, lock it. Then you make sure you put the SD card inside. I put mine already. And then you just put that remaining piece of the cable inside. This is it. This is how well it could look like, and it's like totally robust solution, fully assembled the Raspberry Pi and display module. Now remaining piece is very simple. We take a faceplate and we need to assemble it here. So to do that, there are several options here. First of all, we need again long bolts here. Okay, I'm using Hex one that is 3mm this time. I bought on Amazon as well. And then you need something that can, well, imagine that I put one here, and you need somehow to hold it together. So you, of course, you can put plastic washer, the big one, or you can use this template, which is, by the way, available on a Github with all the other files. So you can use it like this. You see, you can laser cut it from the plastic. It's a plastic, just a white plastic, or yeah, I don't know. You can make a piece of wood or whatever else. And basically then you have screw here. That's how you do it for one. You just repeat it another 3 times. Let me do that quick. By the way, don't forget to remove the plastic protection. It is ready. Check this out. In this assembly, I'm not using any glue here. I just, well, tied it tight enough, and so it holds in place. It's not moving. It will not move. You may decide that you can put, I don't know, like a piece of the double-side Scotch tape. It will work for purpose for sure. If you just need the extra protection. Anyway, it's not moving anywhere, but it really depends what type of a solution you'll be using here. Yeah, you have drawings for this. You decide what will be your own choice. Right, now as we have this full assembled, it misses really small pieces here. One is the USB. Several options here again. This is USB 3.0 extender. I will send the links, of course, that you just put here, and then you connect USB to the interface here. So there are two 3.0 and, I'm sorry, there are two 3.0 and two 2.0 USB. Here is a problem that if you just connect it as is, because I wanted to make the module narrow and don't use more space than I have to, if you connect it like this, it may happen that the module will conflict with other modules in your system. If it's a small module that doesn't go that far, so you can squeeze it in and you can use that, so no problems. Or there is another option. Instead of using that straight USB connector, you can go with several options, most of them available for USB 2.0, which offer you angle connectors or opposite connectors. So like this one, if I connect it like this, you see, the cable goes straight here, and it remains within the space of a module, which is great. That's exactly what we need. You can also use this angle connector, like this, and then you can connect two, like this, and route them here. Or you can use this connector if you want to connect to this port. You see, one goes on the left side, and another one goes on the right side, and do same here. So the extra cable length is not a problem. You just somehow put it all together here, put on a zip tie, or just leave it as is. This is not a problem. Okay, and the final piece of these holes are for the breakout board that I have here. It's very simple board. For TRS connectors, the headers here, and you put it here, and you screw it here, and you mark what it is. This board really depends what audio interface you are going to use. Maybe you decide you don't want to use any audio interface here, you will use it all connected over USB. That's your choice, absolutely could be used. In that case, you don't need this panel at all. Or you may want to use it for MIDI. And the next one, I'm going to explain how you can assemble the MIDI kit called Synth Kit that goes on top of this here. And in the final part, we will assemble it all together. Now let's continue talking about Synth Kit in greater detail. I have assembled Synth Kit board in front of me, and basically it has three main functional blocks on this board that you can mix and match. You can populate some of those, you can omit others. So the first functional block is basically interfacing of Raspberry Pi to Eurorack power. And the only reason you want to use it, if you plan to connect your Raspberry Pi to the 16-pin Eurorack power that's supplied by the Eurorack chassis. If you continue using the USB-C on the Raspberry Pi, this part is not necessary. So it consists of the 16-pin power header, capacitor, diode, a jumper. This jumper basically selects what is the power rail used for Raspberry Pi. And you have two options. Basically, in this position, currently set it's 1, 2, it uses the 5-volt power rail which comes on the extended 16-pin connector. It's not available on 10-pin power connectors, so keep that in mind. It comes on the extra pins here. And the main idea is that basically you feed 5 volts directly into the Raspberry Pi without any conversion. It goes straight. And with that, you solely rely on the power of a 5-volt rail provided by the Eurorack chassis. You have to make sure that Eurorack chassis provides enough power. So Raspberry Pi on average consumes about 1 amp at 5 volts. It can go up to 1.5 during normal operations. It can go up to 3 amps during peak operations. And of course, it consumes more if you have some USB interfaces attached to it, no matter what it is, USB stick or mouse dongle or keyboard, whatever else. So keep that in mind. Because some of the Eurorack chassis, they don't provide the 5 volt, you can actually use plus 12 volt rail. And for that purpose, you need to set it to 2.3. And in that case, you will be using the DC-DC converter here. So again, the whole purpose of this DC-DC is convert plus 12 volts into the 5 volts that's needed for Raspberry Pi. This current version that I'm using here, it's rated to the 3 amps. That's how you buy it. So it comes as a module. There are smaller modules like this. This is rated to 1.5 amp. So, I mean, it's usable. It can get a little bit warm here. I would recommend using just a bigger version to have some extra available, current if it's needed. because you may have some external interfaces connected, and then you certainly may run out of the power budget with this small board. If we look on the PCB board, so you may find that here different pins is just designed to, well, to consume this small board. If it's a 3-pin, again, it's input, output, input, ground, output, that goes here. Or if you're using bigger board like this, it uses 6-pin, where first 2 pins input, second 2 pins ground, and the last 2 output. So you just solder it here. So there are multiple options. There are multiple of these boards, different kinds available on eBay or on AliExpress. Doesn't really matter. So just keep in mind the power budget that you have. I have this board in the BOM link, so refer to this board. It's tested. I'm using it on many projects. So now we solve the power. That's the first function. The second function of this board, again refer to the assembled version, is the MIDI interface. And here we are using, well, very low-cost implementation of the MIDI interface based on the just optocoupler connected straight into the UART pins of the Raspberry Pi. And because it's not USB, obviously it's not plug and play, you have to make Raspberry Pi aware that you're using this circuitry. And you configure that based on the software guide. So again, refer to the software guide. And you also have to run a small application in the background so it can process all the incoming signals over UART and convert it to actual MIDI port data. This is low-cost option. It's proven to work fine, but again, you may decide that USB interface is more preferable. In that case, you may still solder it but not use it, or you may completely omit it, don't populate any of these parts, except this diode and capacitor that's needed for the power circuitry. Similar to this, there's also the power LED and resistor. Here, if you need it, yeah, solder it. If you don't need it, just skip it. And the final place here is the audio interface. I'm using already, well, pre-built board for the audio interface. It's soldered directly on top of this board using just well, regular header pins, same way like you would do the power. And this board is based on the Burr Brown PCM 5102A. That's very good DAC for very little money. So the wholly assembled board costs like, well, roughly $4, including shipping. So that's really low cost solution, but it significantly outperforms the built-in audio interface in Raspberry Pi. It can run at 48 kilohertz, no problems. It can run in low latency. It's connected to the main well, GPIO header with the I2S protocol. And again, there is some extra steps that you have to do in Patchbox or Raspberry to make operating system aware of this board. In the meantime, you also have to set the board appropriately to the interface it's used, because there are multiple options how you can use this board with Raspberry Pi. You can use it with Arduino projects and others. So there are few well, drops of solder you have to put here to set proper configuration, what protocol it uses. Again, refer to the hardware manual. It has all the details of this board, very easy to use, and it has audio output on the TRS connector here, and it also has it doubled on the pins. So if you are going to use the small TRS board, so it makes sense just to solder it directly to these pins. There is output left, ground, output right, and again ground pins. That would be more than enough for the needs of this external just a breakout board. That's pretty much it. So 3 fundamental parts: power, MIDI, and audio output. You can mix and match them, depends what you need. If you don't need audio board, you just skip it. Don't solder it, you will not break any functionality. Similar to MIDI, if you don't need it, don't solder MIDI parts. All of that is part of the instructions with all the components all specified, where you need to solder it, where you can skip it. And similar for the power. Again, if you continue using it with the USB-C Raspberry Pi power and some external power supply, well, do that and just skip these parts, you don't need these. Also, well, some people prefer to use this board. It's really good quality, but unfortunately, audio board doesn't provide audio input. So you're only dealing with audio output. That's why it's called Synth Kit, because you play with MIDI, you output with real audio, or you output with MIDI, depends how you can continue. If you really need the board that can accommodate also both inputs and outputs in high quality, good package, so in that case, I would recommend using something, well, specifically designed for Raspberry Pi, so such as this Hi-Fi Berry DAC and ADC Pro. That's a Pro version. It has the onboard clock, and it has separate chips for DAC and ADC, also Burr Brown. So what you can do then depends how you decide to solder. You have several options. You can stack the Hi-Fi Berry board on top of the well, Synth Kit board. In that case, just make sure that you have enough clearance, so you have to use standoffs. Or otherwise, because there is the like duplicate connector, you can solder the Synth Kit on top of the Hi-Fi Berry board. Similar, you have to make sure that there is enough clearance so you don't short the two boards together. And yeah, and you can continue using it. Anyway, this product is high quality, highly recommended. Of course, you can also use USB attached audio interface, starting from the cheap one that would cost you like a couple dollars to more expensive USB audio class compliant. That's your choice. You can combine this. You can use these together with the USB audio interface too. All right, so we covered pretty much everything but the header. What's important to note that there is also several options for the header that you can use here, because the problem is that this board comes on top of the Raspberry Pi, and that also assumes that you have the well heatsink solution, like I've just talked about that in other part. So depends the width of the heatsink. You need to make sure that you have enough clearance between these two, so you use proper connector. All right, so now let's move to assembly stage. So we are at the final stage of the assembling our Raspberry Pi. As you may find, in the meantime, I just zip tied the USB ports. I put them together, so they all in place right now. Now what's missing? We need to attach the Synth Kit board. And what has changed to this board, I just soldered these two connectors. That is output for these two wires, this for output, for analog output. Again, no any connectors, just straight shielded wires. I could use dipole cables like I'm using for MIDI here. And the trick is that the output left and right, obviously they are mono output, so they only solder it to the sleeve and tip, while the MIDI input and output, it's soldered to ring and tip. And as you may know, there are two specifications available called TRS-A and TRS-B. That is just describes what is the direction. So it would be one side, either another side, depends on the spec. So that happened well over the years. Anyway, if it doesn't work one direction, so you flip it, you change it from TRS-A to TRS-B, and it will work another direction. What you may also see that if I just assemble it like this, so there is not enough room here, I have to use some sort of extender. And as I mentioned in the beginning, you could buy the long connector right away from Adafruit, or you can buy extender I just solder it, as I explained earlier, with just pins to a female socket, so header to a female, and I did it twice, so then I can do that like this. I can attach it here, one and another, and then I attach it there. It will hold in place even like this. You may decide to use standoffs. I'll show you the example how that could be done. Like with this board, what I did, it goes again through the extender here and just standoffs into the holes that I pre-drills, and it locks everything together really well. Okay, so you do the same for this board. And the final one, you put the breakout board outside. This is my configuration, that's how it looks. Put it here, right, and you screw that, put the nut. Never use pliers, use a special tool. Now everything is assembled. This is how you would load the unit. I may decide to put some more zip ties here to make it looking really good. Then you connect the Eurorack power. Keep in mind the red wire should go to down. That is important because red wire brings you minus 12 volts. Don't flip it. Even if you do that, there is a protection diode. Nothing will happen. So that would be your unit. Load it to Eurorack and play with it. Thanks a lot. Enjoy. Now the next step is software guide. Read the software guide. There is no video about this. It's all straightforward. How you set up the touch screen, MIDI, audio, and then you'll be able to play with it. Goodbye.